Hello everyone, and welcome to Geometry Section 1-6, Angles and Their Measures. In this section we'll be getting a definition of an angle. We'll also be learning how to name angles and how to use them in different problems. We'll learn how to classify angles, and we'll also get a postulate that deals specifically with angles. So let's start off with the definition. An angle is a figure that's formed by two rays with the same endpoint. In section 1-3 we talked about what a ray is, and we found out that a ray is a line segment that continues in one direction. So an angle is made up of two rays put together at that endpoint. We have a couple of different terms we talk about when we're talking about angles. First we have sides, and those are the rays that make up the angle. So when we talk about the sides, we're actually talking about those two rays. The endpoint that those two rays have in common is called the vertex of the angle, and that's really important, especially when we're naming angles. And another word that you're going to hear a lot, congruent, means the same size and the same shape. So in this section we'll be talking about congruent angles, which just means angles that have the same measure. So down below here you can see a picture of an angle, and here's its vertex, the point where those two rays come together. And then remember, the sides of this angle are called rays, and that little arc you see down in the corner of the angle is sometimes used to show which angle we're talking about. And you'll see another example that uses this later on in this section. So let's look at how to name a couple of different angles. When we're naming angles, it's important to note where the vertex is. So on this angle, my vertex would be the point S here. Now we have a couple of options when we're naming angles. First, we can name the angle using 3 points on the angle with the vertex in the middle. So I could call this angle RST. I could also go the other way around the angle and call it angle TSR. Now sometimes we have cases like this where there's only one angle at that vertex. So I could just call this angle S. Let's look at another example where that won't work. So in my next angle, I have M as my vertex, and I actually have 3 different angles here. So let's start by looking at the angle that has ray MH and ray MK as its sides. So this angle has M as its vertex, so I could either name it angle HMK or angle KMH. The next angle here, we'll look at the angle that uses ray MK and ray MN as its sides. I could either name this angle angle KMN or angle NMK. Now let's look at this big angle that has rays MH and MN as its sides. I could call this angle angle HMN or angle NMH. Now in the last problem I was able to call that angle angle S, and I could name it just by the vertex. But in this angle I have 3 different angles that all share M as a vertex, so I can't call any of them angle M. Okay, let's look at one more example of this before we move on. So in this angle, again, we have 3 different angles all sharing a common vertex, so I can't name any of these angle J. Alright, so our first angle here, we'll talk about the angle that uses ray JG and ray JC as its sides, and of course your vertex is J, so I could either name this angle GJC or angle CJG. Okay, now let's look at our next angle, the smallest one. It has sides JC and JF, so I could name it angle CJF or angle FJC. And finally we'll look at this big angle, the whole thing, that has sides JG and JF. I could either name this angle angle GJF or angle FJG. And remember, since 3 angles all share the vertex, I can't just use angle J because that could mean multiple angles. Okay, next let's look at classifying angles. We have 4 basic classifications for all angles. Angles can be acute, right, obtuse, or straight. An acute angle is the smallest angle. It measures between 0 and 90 degrees. Next is a right angle. That's an angle that measures exactly 90 degrees. So this is the kind of corner that you'd see on a rectangle or a square. An obtuse angle is an angle that measures between 90 and 180 degrees. Finally, we have a straight angle. This is the largest angle that we'll talk about. It measures exactly 180 degrees. We use straight angles a lot because a straight angle is just a straight line. So we'll use that 180 degrees a lot in some of the proofs and theorems that we have later on in geometry. So if we're going to be classifying angles, we also need to know how to measure them. To measure an angle, we use a tool called a protractor, which is the blue object you see on the screen now. To use a protractor, line the vertex of your angle up with the vertical 0 mark on the protractor. Then you want to turn the protractor so that one side of the angle lies along that horizontal line that goes along the bottom. In my example, ray AC lies along that edge. Then you want to follow the other side of your angle up to the measurements. It's really important that you notice which set of measurements you'll be using. For my angle, I'm using the inside set of numbers, since ray AC lines up with the 0 on the inside set. So following those numbers, this angle measures about 50 degrees. If you get confused about which set of numbers to use, just think back to your classifications. This angle is obviously less than 90 degrees, so I know it needs to be acute, and it should measure less than 90 degrees. The only two options I have where my angle crosses the protractor are 50 degrees and 130 degrees, so I know I should choose 50. Now let's practice classifying some angles. First we have the measure of angle A is 130 degrees, so angle A is obtuse. Next, the measure of B is 90 degrees, so B is a right angle. And finally, the measure of angle C is 45 degrees, so C is an acute angle. Alright, get out your crayons, it's coloring time. Let's see what else we can do with a protractor. How about drawing an angle? Great idea! Follow along with my step-by-step instructions. I make drawing fun! Start with a ray. A nice straight one is a good place to start. Use a straight edge if you have one. Next, whip out your handy-dandy protractor. You know, the one in your back pocket. Line up the end point of your ray with the 0 line on the protractor, just like we did when we were measuring angles. This is going to be the vertex of your angle. Next, turn the protractor so the ray on your paper is in line with the horizontal line at the bottom of the protractor. Again, just like when we were measuring. Let's say we want to construct, which is a fancy geometry word for draw, a 70-degree angle. Follow the measurements to 70 degrees and make sure that you're choosing the set that increases from 0. Put a small mark at the edge of the protractor at 70 degrees. Now use your straight edge to connect the vertex to the mark you made at 70. Congratulations, you just made your first angle. Let's see how the other students are doing.
Hey, I think she's looking pretty good there.
I said a straight ray! A straight ray! Guy wouldn't know straight if it came up and hit him in the face.
That happened once.
You there? Just keep doing your thing, man. Aw, oh, crap. I didn't know you were doing one.
Yeah, and I think I improved on your methods a bit too. I employed a straight edge and a compass, and I even labeled some points and some measurements too.
I'll show you an improvement. Wahahaha! Trogdor strikes again! Now for the really fun stuff, the angle addition postulate. Think back to lesson 1.5. Remember the segment addition postulate? Using what you know about that postulate and a little inductive reasoning, can you make a hypothesis about this next postulate? Hopefully you're guessing that we'll be adding two angles together to make a larger angle, in which case you'd be right. The angle addition postulate says that if P is in the interior of angle RST, then the measure of angle RST is the sum of the measures of angle RSP and angle PST. So in other words, when I break the largest angle, angle RST, into two separate pieces, the sum of the measures of the two smaller pieces still need to add up to the original angle, angle RST. Let's look at a few examples of this postulate in action. In each of these examples, I'm asked to find the measure of angle ABC. In the first example, ray BD cuts angle ABC into two pieces. Angle ABD measures 60 degrees, and angle DBC measures 20 degrees. According to the angle addition postulate, the measure of angle ABD plus the measure of angle DBC has to equal the measure of angle ABC. That little M I'm putting in front of the angle symbols just shows that I'm talking about the measure of the angle, which is a number, not the actual angle figure itself. Using substitution, I'll get 60 plus 20, and then that should equal the measure of angle ABC, and when I add them together I get 80. So angle ABC must be 80 degrees. Let's try another example. In this example, ABC is again split by ray BD. This time, angle ABD is 40 degrees, and angle DBC is 90. Hopefully you recognize that as being a right angle. By the angle addition postulate, I'll have 40 degrees, which is angle ABD, plus 90 degrees, which is angle DBC, adding up to the measure of angle ABC. And when I add them together, I get 130 degrees, so that must be the measure of angle ABC. Alright, one last example. Remember that arc we saw at the beginning of the video? I told you it would come back. Here it is again. In this example, that red arc is showing me that the 135 degrees is the measure of the whole angle, angle ABD. So here I have the two smaller angles, angle DBC and angle ABC, which have to add up to the larger angle, angle ABD. Algebraically, I'll have 60 degrees, which is the measure of angle DBC, plus the measure of angle ABC, which is my variable, equal to 135 degrees, the measure of the whole angle, angle ABD. To solve this equation, I need to subtract 60 from both sides, which leaves me with the measure of angle ABC equaling 75 degrees. That's the end of section 1-6. Remember, you can always go back and re-watch sections of the video if there's anything from this lesson you didn't understand. Thanks for joining me, and happy hypothesizing.